All right, thank you so much for joining us today. So, when we are done with these practice examples, we are going to talk about equation of the line, equation of the plane, and we talk about intersections. And then right after those things, I think we will move to we need tangent, we will practice, and then we take some quiz, and then we'll start my favorite part, differential equation. So stay tuned and let's start. So we have 9 questions that we are going to go through together. So stay here with me. They are very useful. So stay here with me and let's learn how to approach each of the questions, how to understand them, and then how to do them as well. So here we want to show that when I cross two vectors, the same two vectors, I get 0, right? So that's basically what we want to do. So what I'm going to do is, since A is in 3 dimension, 3D, then I'm going to define, let's say, A to be a1i plus a2j plus a3k, right? So that's what I'm going to do. So now I want to show that a cross a is equal to 0. So now let's pick it. So this is I. So you remember that this is a cross product. So you are going to have I, j, k, right? And when you finish, the first component will be here. The second component will be here too as well. All right, so let me see now. This is going to be A1, A2, A3, A1, A2, A3. Good. So basically, that's what we are going to have. So let's do the cross and see. So I maintain my I. This one will cancel that. Then it will be left with this. So I'm going to have A2, A3 minus A2, A3 minus. Don't forget the cofactor. Always plus, minus, plus on the top. Then this one is going to be j. When I cross this and this, I'm going to have a1 a3 minus a1 a3 plus k. And when I cross the k out, a1 a2 minus a1 a2. And guess what? This is going to give us, this is 0 because they are the same term, minus another 0 plus another 0. So this is going to give us 0. Right. So this is kind of very simple. So basically, that's all you need to do to prove that, or to show that A cross A is equal to 0. Let's look at question 2. Now show that A cross B is orthogonal to A and B. So when we talked about orthogonal, right? And we said orthogonal is the same as perpendicular. So that is what we need to remember here. So when you say something is perpendicular, remember, for us to show that it is perpendicular, we have cross product and we have the dot product. For us to show that something is perpendicular, then we need to dot them. So remember that we said when you cross two vectors, you get a vector. So it means that when I cross A and B, I'm going to have a vector. So now, since we want to show that this vector is orthogonal to A and B, then it means that we need to dot this vector with A and then also this vector with B. Right. So instead of finding vector of AB before we dot with this one, we can just show that A dot A cross B is equal to 0, and then B dot A cross this one is also equal to 0. As I said, dot product is commutative. So you can just do something like A cross B dot B is the same as this, is the same as this, because this is going to be a vector. Let's assume that it is D. So this one will be D dot B, and this is the same as B dot A. So dot product is commutative, but cross product is not commutative. Good. So that is what we just basically want to show. So before we do that, we can just move to, say, let's say A1, A is equal to A1I plus A2J plus A3K, and then we can also define B to be B1I plus B2J plus B3K. Right. So let's go through, let's show them one by one and show that it's equal to 0. So A dot A cross B is going to be, so since there are 3 of them, 1, 2, 3, this will occupy the first, this will occupy the second, and this one will occupy the third. So I'm going to have A1, A2, A3, A1, A2, A3, and then this one is going to be B1, B2, B3. Right. So now let's do the same thing. So you see that when you do this, you become very fluent with it. Like you can just close your eyes and just pick the terms straight away without picking the second derivative and then before I said second derivative, the second matrix. I mean, if I cross this, if I do it and do it, there's no need for me to write A this, A3, B3, B2, B3, right? Because I've been doing them, right? But I'm just writing them. Then minus A2, A1, A3, B1, B3, plus A3, I'm going to have A1, A2, B1, B2, right? So basically this, it will be left with this, it will be left this, and that, which is here. And then the last one will be left with this also here. So still we are using the cofactors, plus, minus, plus, minus, plus, minus, plus, minus, plus. Good. So let's just simplify and see what we are going to get at the end of the day. So A1, this will be A2B3 minus A3B2 minus A2 A1B3 minus A3B1 plus A3. Let me shift this one small here. So this is basically going to give us A1 B2 minus A2 B1, right? So that's what we are going to get at the end of the day. Let's multiply through by this. So we are going to have A1 A2 B3 minus A1 A3 B2 minus, when I multiply this one through, I want to arrange it well. So I'm going to have A1 A2 B3 minus, this one will be A2 B3, no, A2 A3 B1 plus, when I do this one is going to be A1 A3 B2 minus A2, another A3, and then B2. So we see that A1 A2 B3 will going to cancel someone like, oops, I think this one's supposed to be positive because we want to multiply through by minus, so this one become positive. So this is going to cancel, this is A1, A2, so let's go for A1, A2, B3, good. So this one will cancel this. And then we know that this one, A1, A3, A1, A3, B2, also cancel that. So green cancel the green. And then definitely the last term will cancel this term. So we are going to have 0. So the red cancel the red, the blue cancel the blue, and then green cancel the green. So we've shown that this is equal to 0. So the next thing that we need to do is we just need to go by this one too, like showing that this one too is equal to what? 0. Then we are done with this question. But I think I can just leave it out for you to practice, right? Just quoting down this one already here and just practice. Basically, we are going to get 0. So yes, but yeah. So there's no need for you to put your final result in the comment section. So practice this one and see that if you are going to get 0 using the same, this one here. So here the first component here will change to the B component, and then the same thing here. Then you work it out. All right. Let's look at question 3. Show that vector A, B, C are coplanar. So remember coplanar, right? So we said that with the scalar triple product, when you're talking about coplanar, we are talking about when the vectors are in the same line, right? In the same plane, they are parallel to each other. So it means that for coplanar vectors, then we have A dot B cross C should be equal to 0. So that's basically what we just need to do here. So it means that if indeed they are coplanar, then they should be equal to 0, as it is saying that we should show. So basically that's what we want to do. So we know A, we know B, we know C from the component that we have here. So A is I plus 4j minus 7k. B is equal to 2I minus j plus 4k. And then C is equal to minus j plus 18k. So let's do that. A dot B cross C will be equal to, I have this one here. So the first component should be on the top. So I'm going to have 1, 4 minus 7. I'm just picking the coefficient of direction, followed by B. So 2 minus 1, 4, followed by C. And then the C, we don't have the I direction, so it means that it's 0. So 0 minus 1, 18. So I just need to show that this is, basically 0. But, with determinant, you can always, it's not always the case that you need to choose this. You can choose this, you can choose that, you can choose this, any of them works. But always you need to be smart. Like, for example, when you are doing linear algebra, right, which is going to be in level 300, and then when you are doing linear algebra, it's like you are doing determinant which goes with 4 by 4 matrix. So for you to go fast, you would like to pick the one with zeros, whether on the row or on the column, so that you can ignore them. So this one, if I pick this one, then it means that this one term will be just going to 0. So basically that's how it's supposed to be. But I'll choose the first row because we are just doing it. So when you finish, you can be changing the rows, like picking it from different angles and see if you're going to get the same results. So this is going to be 1. Then I have minus 1, 4, minus 1, 18, minus 4. Then I have 2, 4, 0, 18. Then I have minus 7. Then I have 2 minus 1, 0 minus 1. So always don't forget the cofactors. It's very important. Minus, plus, minus, plus. Good. These are the cofactors. So I'm using the top one. That's why I have plus, minus, plus. This minus here is because this guy is minus already. So I'm going to have 1 times minus 18 minus 4, right? So this times this minus this times that minus 4. 2 times 18 should be 36. 36 minus 0, and then minus 7 times minus 2 minus 0. So the idea is that at the end of the day, we should get 0. If we are not getting 0, it means that we are getting something wrong. So this one is 1 times minus 18 plus 4 minus 4 times 36 minus 7 times minus 2. So this is going to give us minus, I think 14, right? Yeah. And then minus, so let's look at something like this. 36 times 4. 36 times 4. So 36 times 4. This is 24. 2 here, 12, 1, 4, 4. 1, 4, 4. And this one is going to be plus 14. Indeed, there should be something wrong with our question here, because basically this will cancel this, and then in the middle, something is wrong. Let's go and check it out. 1, 4 minus 7, 2 minus 1, 4. And then, okay, so let me check it again. Okay, 2 minus 1, 4, 0 minus 1, 18. 18. Okay, so let me see it again. So cancel this one out. Okay, cancel this one out. 2, 4, 0, 18. And cancel this one out. 2 minus 1 that. So this is this one here. This times this. And this one will be 0. 18 times 2 is 36 indeed. Then this times that is going to be this. And this will be 0. So we are going to have it to be minus 4, 144. Yeah, so basically the question is kind of wrong because we are not getting 0 because we should get 0 at the end of the day. So maybe some of the values, maybe when I was typing, I didn't put in the right value. Yeah, maybe because it should be getting 0 from there. It should be getting 0 from there. All right. So I don't know whether is there any mistake? No. So yeah, let's put asterisk on this. So basically, that's how you can solve coplanar vectors, right? All you need to know is you do the scalar triple, and they should be getting 0 at the end of the day. If you are not getting 0, this is wrong. This question too did not tell us show whether or not. So it means that the question is wrong. I'll check it out. Maybe I'll check it out and put the right component in the comment section. Now let's look at question 4. Prove that vector A, B, C, and D are coplanar. Another coplanar again. So what we just need to do is, this one we have 4 vectors. So basically, we as I draw this one, A, B, C, and D, we need to find vector from A to B, and then from A to C, and from A to D. So basically, that's what we need to do. So if I'm using big A's, and then I'm going to have vector AB, I need vector AC, and then I need vector AD, right? So that is how we form it. So this is going to be small b minus small a, small c minus small a, and this one is going to be small d minus a. So all of them is given in the question. So we just need to figure it out, and then we are there. So what is b? B is minus j minus k minus what is a? 4i plus 5j plus k. So let's solve that. This is going to give us j minus k minus 4i 5j minus k. So this is going to give us we have I, yeah, so minus 4i minus 6j and then minus 2k. So that's what we are going to get for AB, right? Let's look for AC. So AC, C is 3i plus 9j plus 4k minus A is 4i plus 5j plus k. So let's solve that. Let's try and simplify that. This is going to be 3i plus 9j plus 4k minus 4i plus 5j, no, should be minus k. So this is going to give us minus I plus 4j plus 3k. Another one that we need to do is we have D is 444. So minus 4i plus 4j plus 4k minus A is 4i plus 5j plus k. Simplify that, minus 4i plus 4j plus 4k minus 4i minus 5j minus k. This is going to give us 8i minus and then minus j plus 3k. So we have all of them. Now we form AB, AC, and then AD. So same thing, coplanar. For coplanar, when we find A dot AC cross AD, you should be getting 0. So that's what we just need to do. Okay. So let's put them in, and then let's see what you are going to get at the end of the day. AB is minus 4, so 4, 6, 2. Minus 4 minus 6 minus 2, which is here. And then AC is minus 1, 4, 3. Good. And then the last one, which is minus 8, minus 1, and 3. Good. So that's what basically we are going to get. Okay, so let's go through quick. and then we see what we are going to get. So let me shape this one small. Okay. So I'll just write -4 and then just do it straight. So this time this will be 12, and then this time this will be +3, -6. So minus will be plus. Here will be minus. This is a minus, will be coming plus. Then I cancel this, cancel that. Then I have this times this will be -3. Then when I cancel this and this times this will be plus. 3 times 8 should be 24. -2. Cancel that and that. It will be left with this. -1 times -1 is going to be 1, plus 8 times 4, I think it should be 32. I hope this one gives us 0. So -4, this is going to be 15 plus 6, and then this one is going to be 21, yeah. And then this one will be -2, this is going to be 33. Yes. So 4 times 15 should be minus, is it 60? Yes. Yes, I'm right. And then 21 times 6, this one will be 6, 126, right? Yeah. So it's going to be plus 126. And then this is minus 2 times 33 is going to be 66. Indeed, this is going to be 0. Yes, because this is the same as minus 126 plus 126. And this one gives us 0. Good. So this one was indeed right. Yeah. So basically, you see, when we solve more example, we get used to the terms. And then when I see the question, I just know what I'm going to do. Period. That's all. And then I'm done with question 4. Let's look at question 5. Find 2. So the question is 2. Find 2 unit vectors. So the question, what is a unit vector? A unit vector is a vector that has a magnitude of 1. So now the question is, we should find 2 unit vectors orthogonal to A and B. Good. So we have 2 ways of getting this. I'll pick the scalar triple product, and when I finish, I'll come and explain the other one. So the first thing that we need to do is, with this one, if we are using the cross product or the scalar triple product, then what we need to do is, now we are going to, let's assume that we have C, right? So C will be equal to A cross B, right? So that is one way of getting a vector. So we are assuming that this vector here, this vector C here, is orthogonal to A and B, right? So I'm going to have I, J, K. I'm going to have 1, 1, 0, because I don't have K with this one. Then I'm going to have 1 minus 1 and 1. Good. So let's go through and see what we are going to get. I cancel this. It will be left with this one. So multiply. We are going to have 1 minus 0 minus J. Cancel this one out. 1 times this and this times that. So I'm going to have 1 minus 0 and then plus K. Cancel this out, cancel this out. It will be left with this. So I'm going to have minus 1 minus 1. Is that right? Yeah. This times this minus this times that. Good. Indeed. So we are going to have something like I minus J minus 2K, right? When we simplify this. This one will be I, this one will be minus J, this is minus 2 times this will give us this. So this is our vector C, right? So vector C is the vector which is perpendicular to A and B. We want to find the unit vector of that. So for us to find the unit vector, we said the unit vector is equal to the vector C divided by the magnitude of C, right? So now that we know this vector C here, we need to find the magnitude, and then we just divide. Then we get one unit vector out of it. So what is the magnitude of C? We know how to do magnitude, right? So this is just pick the coefficient of the direction and square it. So I'm going to have 1 squared plus minus 1 squared plus minus 2 squared. So I'm going to have 1 plus 1 plus 4, and this is going to be like square root of 6. Right, so that's what I'm going to get at the end of the day. So the unit vector is going to be I minus j minus 2k divided by root of 6. So this is one of the unit vector that we need to find. This is one of it. What is the other one? The other one too is kind of a long journey, but a long journey cut short. Remember when we started Coplanar, we talked about this unit vector, right? So now since now we want to find the other unit vector, what we are going to do is, now we have another information that says that the vector is orthogonal to A and B. So what we can do is, for us to find the other one, what we are going to do is very simple. We are going to define a new vector C, which I'm going to call it C1i plus C2j plus C3k, right? And then now, since I know that this vector is orthogonal to A and B, it implies that A dot C should be 0, and then B dot C should also be 0. So basically, that's what we need to do. So this one will also help us to find the other unit vector, right? So at least let me make this one D so that it changes that one with the other one. So this one will be D1, D2, and this one will be D3. So this one will be D, this one will be D. So now what is A dot D? So this is A, this is D. So when you want to dot two vectors, you remember what we do. We just need to multiply the same directions. So D1i plus D2j plus D3k. So when I want to dot it, I dot I squared is 1. Don't say minus 1. Minus 1 is in complex analysis. Here we are getting 1. Okay? All right. Then j times this one is going to give us plus D2. Here we don't have k. So we assume that it's 0. So when I multiply by this one, I'm going to get 0. And we know that A dot D is equal to 0. So this is equal to 0. Equation 1. Or I can say that from equation 1, I can make from equation 1, or from here, I can say that this implies that D2 is equal to minus D1. Equation 1. Then I move to B dot D. What is B? B is ijk. So we have I minus j plus k times D1i plus D2j plus D3k. So we are going to have this times this times that, and this times that. So we are going to have D1 minus D2 plus D3. And remember, this is equal to 0. So this is also going to be equal to 0, equation 2. So as I said, you see, we have 3 variables with 2 equations, right? We are finding 3 variables with 2 equations. So it's always the case that we cannot find all the variables. So what we can do is we can express them in one variable. So we want to express this D in terms of just one variable. Let's say D1. So since I've made D1 the subject here, which is D2, I'll put D1 inside this equation here. So let's do that. Put equation 1 into equation 2. So we are going to have 0 is equal to D1 minus D1 plus D3. Because D2 is this, and it's minus, so minus minus. So this is going to give us 0 is equal to D1 plus D1 plus D3. So this implies that 0 is equal to 2d1 plus d3. So this implies that d3 is also equal to minus 2d1. So you see what we've done now? Now we have d2 in terms of d1, and we have d3 also in terms of d1. So it means that we were able to write it in terms of only one variable. So this one will help us to write our d, right? So now we know d2, we know d3. So let's do that. So this implies that d is equal to d1i plus, what is d2? d2 now is equal to minus d1. So this is going to be minus d1j, and then d3 is this, so minus 2d1k, right? Because we know that our d is equal to d1i plus d2j plus d3k, and we know that d3 is equal to this, so we replace it, and we know that d2 is also equal to this. Where is it? Here. So we do the replacement. So now this is the vector that we are talking about. So when I just want to simplify, I can have d1 out, and to be left with I minus j minus 2. So what do you see here? It's, look at this. Look at what is here. This is ijk. ijk. Almost the same thing. But the only thing that is changing here is this guy here, right? That's this guy there. Yeah. So let's see what we are going to get at the end of the day. Let's see what we are going to get at the end of the day. Let me see. Is there a mistake somewhere? No. This and that is right. This is minus, so it's giving us this one to be minus, and this one is going to give us the 2, which is going to be positive, and this one is going to be minus, right? Okay, so we are doing great job. So now what we are going to do is, since we are talking about unit vector, then the unit vector of this should be the vector d divided by the magnitude of d. So what we just need to do is we need to find the magnitude of this. So what is the magnitude of that? So magnitude of d, since d is a constant, I just maintain my d1 out and then pick square root of this. So this one will be 1 squared minus plus minus 1 squared plus minus 2 squared. And this is going to give us, guess what I'm going to get from here? This is going to be something like d1 square root of 6. Is that true? Yes. This one will be 1. This one will be 1, 2. This one will be 4, 6. So that's what we're going to get. So at the end of the day, we are going to have d1 I minus j minus 2k divided by d1 root of 6, and then magic happens, and we have it to be d1 to be equal to I minus j minus 2k divided by root of 6. Yeah. So you see that we use the other one to find for C, and we use this one to also find for the D. So this one gives us 2 unit vectors. All right. Let's look at question 6. Question 6, we have this, and this, and that. We want to show that this is what? Parallel. So basically, I'll show you this, and then maybe I will leave it to you to show, right? So let me assume that the first one, which is this, is A. So this one, we have it in directions, right? Or in the plane form. So remember, X goes with I, Y goes with J, and Z goes with what? K. So this one is going to be just I minus J plus K. Let me make this one B. So this one is going to be I minus 3J. So I pick the coefficient, go with the I. So 1I minus 3J. But here there is no Z. This is just a constant. So you just throw it away. So this one is going to be this with no K. When I come here, I don't have x, so there will not be I. So I'm going to have 2j plus k. Then the last one, which is d, I have x, y, z. Okay, so this is going to give us 4i minus 2j plus 5k. So since we want to show that these lines are parallel to each other, what we just need to do is, you remember this, right? A, B, C, and D. So what we just need to look for, we look for AB, AC, and AD. So they are on there. So we need AB, vector AB, vector AC, vector AD. So this is going to give us something like this, small b minus a, and then this is going to give us small c minus a, and this is going to give us small d. This is going to give us small d minus a. Good. So this is small d, small c, small b, and small a. So when you are done, this is what you just need to do. Look for AB cross dot AC cross AD and put your final results. Oh, this one is supposed to give us 0 actually, because we are showing that this is parallel. So confirm and see if you are going to get 0. But I think the one that I want to inspect is, I want to inspect this and this and that. You can put it in the comment section for me to see. So try and find for this. I think it's just simple. You can even use your eye to just do it. But practice, if you are not even putting in the comment section, find for this. When you finish, make sure this one is equal to 0. Let's look at question 7. Question 7. If A and B are non-collinear, good. Non-collinear means that basically they are linearly independent, right? Linearly independent. So it means that, A and B are not on the same line, right? So now we have A which is equal to this, and we have B which is equal to this. Find x and y such that 3a is equal to 2a. Okay. So 3a, let's find for 3a. So this is our a, which is the whole of this. So we are going to have 3 times the whole of that, which is x plus y a plus 2x plus y plus 1b. So multiply that gives us 3x plus y a plus 2x plus y plus 1b. So this is 3a. Let's look at 2b. 2b will be y minus 2x plus 2a plus 2x minus 3y minus 1b. So multiply, you have this y minus 2x plus 2a plus 2x minus 3y minus 1b. So now we want to equate this and that, but we know that 3a is equal to 2b. So what implies? This implies that this is equal to this. So we are going to have 3x plus ya plus 2x plus y plus 1b is equal to 2y minus 2x plus 2a plus, make a shift, plus 2x minus 3y minus 1b. Now, since they are non-collinear, then it means that the a term or the coefficient of the a term on the left is the same as the coefficient of the a term on the right, right? So the coefficient of a here is this. So we are going to have 3x plus y to be the same as 2y minus 2x plus 2. Because this is the coefficient of a, this is the coefficient of a, so they should be the same. Similarly, the coefficient of b on the left and the right should be the same. So we are going to also have, let me put this one here and put this one here. 2x plus y plus 1 should be the same as 2x minus 3y minus 1. So all we just need to do is we need to solve green and red simultaneously and we are done. But let's simplify. So this is going to be 3x, right, plus 3y is equal to 2y minus 4x plus 4. So this is going to be 3x plus 4x plus 3y minus 2y, which is equal to 4, right? So I just move this and this to the left. So I'm going to have 7x plus y is equal to 4. So equation 1, then let's work with the red. 6x plus 3y plus 3 is equal to 4x minus 6y minus 2. Move x and y to the left and move the constant to the right. We're going to have 6x minus 4x, 3y plus 6y is equal to minus 2 and minus 3. So this gives us 2x plus 9y is equal to minus 5. Equation 2. So all we just need to do is we need to solve equation 1 and equation 2 simultaneously. We have a lot of ways that you can work through this. But for me, I try to use the elimination method, right? So elimination method is I try to eliminate one of the variables. So since the coefficient of this one is 1 and this one is 9, for me to eliminate the y, I need to make sure that the coefficient of this one too is 9, right? So that I can eliminate. So I'm going to multiply equation 1 by 9 so that the coefficient of this and this will be the same. So 9 times 7, so like I'm doing 9 times equation 1. So 9 times 7 should be, I think, 63. Yes, because 7 times 10 is 70. 63x plus 9y is equal to 4 times 9 should be 36. Yeah. So this is our new equation. Let's say equation 3. So I want to combine these two equations, right? So let me use the red to write it. So here is 2x plus 9y is equal to minus 5, which was the equation 2. So I'm going to subtract because this is positive, this is also positive. So what are we going to get at the end of the day? I'm going to have 61x and then 9y minus 9y will be 0. So this one is going to be, now this one will be 36 minus, which is going to be 41. So x should be 41 divided by 61. I think I'm right. Yes. Then now that we have this guy, we can find y, right? So we can just plug this one inside equation 3, inside equation 2, inside equation 1 or equation 2. But I'll plug it inside equation 1 so that I won't struggle a lot. Yeah. So let me just plug it inside equation 1. So equation 1 is 7. X is 41 divided by 41 plus y is equal to 4. So, can 7 divide 61? I'm not sure. This is a lot. Okay, so I'll do it this way. Y is equal to 4 minus 7 times 41 divided by this. I don't have a calculator, so I'll do it manually. 41 times 7. 7 times 4 is 28. Is that right? Are you sure? Yeah, that's right. So 4 minus this divided by 61. And basically, you can use calculator to check out what you are going to get for y, right? But basically, I can also do that. Okay, let me just finish it up by providing the answer for you guys. So yeah, so I can write this one as 61 times 4. This one will be 4. 6 times 4 should be 24. Is that right? Yes. So this is going to be 244 divided by 61 minus 2 this divided by 61. So my y should be equal to 244 minus 287. So let me turn it so that I can, when I finish, I will negate it. So this one is going to be 3, this one is going to be 4. Oh, so minus this divided by 61. You can use calculator to check if I had it right. I'm just using my mind to compute it. Next time I'll buy a calculator. All right. Okay. So let's look at the last two questions. We have question 8 and we have question 9. Then we are done with this video. Now, I love this question because we want to find the equation of the plane which passes through the point, this, that, and that. So remember the equation of the plane from the previous video, right? So we said the equation of the plane is of the form ax minus x naught plus b y minus y naught plus c z minus z naught is equal to 0. So this is the equation of the plane, right? This is the equation of the plane. So I can write something like the equation of the plane is given by. Yeah, so this is what we have. Remember we said A, B, C are the coefficient of the ij direction of the normal vector. You remember that? And then x naught, y naught, z naught is any of the component here. Remember this is the same as this is x naught, this is y naught. That's how we are assuming this is z naught. The same thing applies to this. X naught, y naught, like if we are finding equation of the circle, right? Good. So like I say equation of the circle, equation of the line, right? So we can pick any of them and just plug them in. At the end of the day, we are going to get the same result. So for me, I'm going to choose P to be my x naught, y naught, z naught. When you are watching this video, you can pick any of them. You can pick Q or R, and then when you finish, if we find A, B, and C, we expand. We need to get the same thing at the end of the day. So when I do that, since I'm choosing P, which is 1, 3, 2, to be my x naught, y naught, z naught, then my equation of the plane will be ax minus 1 plus b y minus 3 plus c z minus 2 is equal to 0. So I just need a, b, c. A, b, c are the x, y, j, or let me say x, y, z of the normal vector. So what is the normal vector? The normal vector is equal to, this is, we have 3 of them. So the normal vector will be P, Q, cross P, R, right? So we have P, we have Q, we have R. So we move from P to Q and we move from Q to R, forming 2 vectors, right? And then we cross them and it gives us the what? The normal vector. So now let's look for PQ. PQ is small q minus small p, and this is going to give us, so let's form small p, small q. So small p, small q, and small r. Small p, which is the position vector, will be I plus 3j plus 2k, right? Because it says 1, 3, 2. And then q is 3, 1, 6. 3, 1, 6. So 3i minus j plus 6k, 3, 1, 6. Okay, 3 minus 1 is 6. And 5, 2, 0. 5, 2, 0. So 0 means that this is plus 0k. So this is our small p. So let's use that one to form this. So this is going to give us Q is 3i minus j plus 6k minus p is I minus, no, plus 3j plus 2k. So let's simplify that and see what we are going to get. 3i minus j plus 6k minus I minus 3j. This is 2i minus 4j plus 4k. So we need to find the last one, which is PR, which is small r minus small p. R is 5i plus 2j plus 0k minus p is I plus 3j plus 2k. Simplify that. 5i plus 2j plus 0k minus I minus 3i minus 2k. So this is going to give us something like 4i. Is that right? 4i and then minus j and then minus 2k. Is that right? Yes. This and this will be 4. This and this will be minus 1, minus 2. So we have this guy and this guy. So we just need to find a cross so that we can get our normal vector. Then just come and plug it inside this. So our normal vector n, which is the same as PQ cross PR, is equal to IJK. What is PQ? PQ is 2 minus 4, 4. And then PR is 4 minus 1 minus 2. So that's what we just need to do. So let's just solve and let's go. So maintain I and then cancel this one out. So it will be left with these guys. So we are finding the determinant 2 times minus 4 and then this time is that. So 8 plus 4 minus j, cancel this and this out, and it will be left with 2, 4, 4 minus 2. So this times this will be minus 4 minus 4, 4, 16 plus k, cancel this guy and this guy out. It will be left with this, find the determinant, minus 1 times 2, this times that. So you are going to have minus 2 plus 16. Indeed, this is beautiful. So for me to get a space, I'll just move this guy here and then maybe shift this guy top small, and then you people too should go up small, and then finally we move so that we get space. So this is going to be 12i, and then this will be minus 20 times minus will be plus 20j, and then this is going to be plus 14k. So indeed, this is the normal vector, which is of the form ai plus bj plus ck. So this implies that a is equal to 12, b is equal to 2, 0, and then c is equal to 14. Boom. So we just need to put these ones in front of this, that, and that, and then we are done. So we are going to have a is 12. So we have 12x minus 1 plus b is 20, 20y minus 3 plus c is 14, 14z minus minus what? Minus 2 is equal to 0. So you will see that when you pick different points, let's assume that you are picking this one will be minus 3, this one will be plus 1, this one will be 6. But when I expand by multiplying through by the 12, 20, and 14, and you simplify, you see that we are going to get the same 12x, 20y, and 14z. But the constant, when you multiply and simplify, you are going to get also the same constant at the end of the day. So that is how we solve equation of the plane. And in the next video, we'll be talking about equation of the line and equation of the plane, giving position vectors and directional vectors. And we will learn how to go about that. And then when a point is also given, how we are going to go about that. All right. So now let's look at question 9. I mean, that's the last question for the day. So let's finish it up. So we have this that we want to work with, right? So we want to find A, B, and C such that these guys are the same, right? So this one is like a linear combination. So we have VIN 4 is equal to A VIN 1 plus B VIN 1, no, VIN 2 plus C VIN 3. So what is VIN 4? VIN 4 is here. So we have I plus 2J plus 5K, right? Which is equal to A. What is VIN 1? VIN 1 is here. So I minus 2J plus K plus what is VIN 2? VIN 2 is this with that. So this is I plus 3J minus 2K. And then plus C3. What is VIN 3? The last one there, which is minus I plus J minus 3K. So let's see what we can do. What we are going to do is we are going to expand the right group items with I, J, K, then we equate it to the left. So this is the same as AI minus 2AJ plus AK plus BI plus 3BJ minus 2BK plus minus CI plus CJ minus 3CK, right? So let's group items with those with I. So we have I. So this is going to give us A plus B minus C I. So I, and I, right? Let's go with those with J, right? So those with J is J, J, and J. So we are going to have plus minus 2A plus 3B plus CJ. And the last one is those with K. So K, K, and then K. So you are going to have plus A plus minus 2B minus 3CK. And this is the same as I plus 2J plus 5K. So we are going to equate this to this. So what's the coefficient of I here? 1. And what's the coefficient of this? So this is going to give us A plus B minus C is equal to 1. Say equation 1. Then we pick the coefficient of this, equate it with the coefficient of the J here. So minus 2A minus 2A plus 3B plus C is equal to 2, equation 2. And then the last one is this and that. So we are going to have A minus 2B minus 3C is equal to 5, equation 3. So this one we are fortunate we have 3 equations with 3 unknown. So we can work out all of them nicely. So now the thing is on us how we are going to do that. So I'll do elimination. I love elimination. So for example, equation 1 and equation 3, I can see that the coefficient of A is just standing alone. So I can just eliminate that one out. So I can say equation 1 minus equation 2, equation 3. So this minus this will be 0. This minus this is going to be positive 3b, right? So this minus this. And then this minus this is going to be plus 2c, which is equal to this minus this is going to be minus 4. So this indeed, I was able to find something like this. So I can make, let's say, um, let me hold on with that one. Then let me pick any. So we did equation 1 and 3. So I can look for either equation 1 and 2 or equation 2 and 3, one of them. That can help me to eliminate A again, right? So the idea is that I want to eliminate A again because I eliminated A from here. So the same thing. So what I can do is I can pick equation 1 and equation 2. But for me to eliminate A, I need to multiply this one by 2. So I'm going to multiply equation 1 by 2, which was going to give us 2a plus 2b minus 2c is equal to 2, right? Let me call this one equation 4. Then what I'm going to do is, since this is minus and this is positive, I'm going to add. So equation 2 plus equation 4. So this plus this will be 0. This plus this will be 5b. And then this plus this will be minus c, and then this plus this will be 4 equals to 4. So what am I getting now? I'm getting this equation, and then this is equation. So I was able to making sure that I move the equation, let me say, from 3 unknowns to 2 unknowns, right? So now since this is 2 unknowns, I will be able to solve for b and c. Then when I'm done, I'll use b and c to find for a in any of the equation given out. So what can I do here? From this equation, let me say this is equation star, and this is equation star star. So what I'm going to do is I want to eliminate again another one variable from equation star and equation star star so that I can find the other one. Or what I can do is I can say that, let me write this one as, I can make C the subject by saying that C is the same as 5b minus 4, and call this one equation star star. And then I will say that put equation star star into equation star. So any of them, this is kind of like how you are going to making sure that this guy, you guys are using calculator, so you can even use calculator to find out this. So this is going to be 3b plus 2 times c now is 5b minus 4 minus 4. So 3b plus 10b minus 8 is equal to minus 4. So this one will be 13b is equal to minus 4 plus 8. And then this is going to be 13b is equal to subtract, and you get 4. So b is 4 on 13. It's quite not nice. I want whole numbers. These guys will make the thing very difficult for us. So let's look for c. So since we know b, this will be 5 times 4 over 13 minus 4. So this is going to give us 20 divided by 13 minus 4. And this is 20 divided by 13 minus 13 times 4 is, this is 242. Is that right? No, it should be 52 rather. Yes. So this one will be 52 divided by 13. So this should be, is it 32 divided by 13? Yes, indeed, that's right. So now we have C, we have B, we can find for A, right? Can I give you the A there? Let me give you the A for you to find for the A as an homework, right? So we have C, we have B. So pick this component for B and this component for C and plug it inside, let's say this, and find for A. Or you say I should do it myself. Okay, here I'll do it myself. So A, what is B? B is 4 on 13. So plus 4 on 13 minus C is 32 on 13. Let me do it myself. They will be saying that when I do the work, I don't finish. Okay, so this will be A. When I do the subtraction, I'm going to have minus 28 divided by 13 is equal to 1. And then a will be equal to 1 plus 28 divided by 13. And I'm not using calculator, so I can say that this is 13 divided by 13 plus 28 over 13. And then I'm going to have, add it and see, we get 41 over 13. Good. So this is the end of the video. So in the next video, what we are going to do is we are going to talk about intersections, equation of the line, equation of the planes. And when we are done, we talk about we need tangent, not in the same video, I mean, when we proceed from there. And then when we are done with vector algebra, I will try and then we do a quiz in the YouTube like this, like I mean previous quizzes, and then I'll bring a sample quiz too. And then we practice on how to solve a quiz questions and then, guide you before we start my favorite part, differential equation. All right. Thank you for joining us. Always making sure that you share the video with your friends to making sure that they understand what is taught in class. All right. See you in the next video.